Alright guys, this is the video for solving quadratic inequalities. Please make sure that you take good notes. I'm only going to do one thorough example in here, and then I'll have an additional video with an additional example in there for you to see it. So real quick, I just want to review solving inequalities. Remember that when you divide by a negative number, your inequality sign changes. So I'm just going to go ahead and solve this. Negative 6n less than 24, divide by negative 6. On both sides, because we did divide by a negative, our inequality sign has changed. Okay, if I want to graph that solution, and if you're confused, you need to go way back to the beginning of the year in review. Okay, you can Google this and find a bunch of stuff. Okay, so n is greater than negative 4. Easy peasy. Open circle because there's no equal sign underneath the inequality, which means that our solution set does not include the number 4. Okay, now if you want to check the solution, what you do is you pick an arbitrary number in the region that is included in the solution, okay, and then you plug it back into your original equation to see if you get a true statement, and that's what you're looking for. So I'm just going to pick a random number greater than negative 4, so 0, because it's easy. So I'm just going to plug it back in. Negative 9 minus 6 times 0 less than 15, that goes to 0. Negative 9 is less than 15. That's a true statement. Okay, so that's what we're going to be looking for. In the next slide, the one I'm not going to go over it, just write down all the stuff. That's what we're going to be. This is what we're going to be doing when we check our solutions, and you're going to be looking for true statements. And I'll go over that a little bit more in the example. Alright guys, so here's our first example. We're going to solve this quadratic function to find the values of x such that it is less than 0. So we're just going to start by solving. A is 2, b is 7, and c is equal to negative 4. So if you just kind of visualize what's going on here, you know that this parabola is going to open upwards because a is positive, and it's going to cross the y-axis here at negative 2. So we have something going on that looks something more or less like this. Okay, you could solve for the vertex if you want to, but that's not really important right now. So I'm going to go ahead and use the quadratic function. So our first step was to solve, or the quadratic formula, sorry, because it's just easy. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to plug in our values. 7, 7, 2, negative 4, 2. This is all x equals. So we're solving for the values of x where this is 0. So what I did was I actually just set this equal to 0 in order to solve it. So you should know by now that what we're going to find at the end are the points where our parabola crosses that x-axis there, okay? Because here, that's where y is equal to 0 on that axis. So let's go ahead and solve for those numbers, find those points. So that's negative 7 plus or minus square root of 49. You plug that into your calculator, you get 32 all over 4. That's going to simplify. Well, it's going to become 81 over 4, which is 9. Okay, and that's where you can split it up into your 2. So negative 7 plus 9 over 4 is going to give you 2 over 4, 1/2. Okay, so we found one of the solutions. Find the other one. Negative 16 over 4, negative 4. Okay, so those are the two values for x. So we have x is equal to 1/2 and negative 4. So that's the value of these points over here. Okay, I've got negative 4 on the left and 1/2 on the right. And that's just to give you a visual. So what I'm going to do is I'm going to show you how to do it algebraically, which is what we're doing over here in black. And then also graphically, I'm going to show you visually what's actually happening over here on the sketch in the corner over here. So kind of follow along with both. So that's our first step. The second step was to do your number line, and then next was to check your solutions. So what I mean by that is I mean literally draw a number line. Now please be accurate, negative numbers on the left, positive numbers on the right. So our two solutions, we have 1/2 and -4. Open circle, okay, back to the inequality, it's less than, okay, open circle. So remember, less than, greater than, or equal to is a closed circle, less than, or greater than and less than is an open circle, okay, which means that our solution cannot include the points -4 and 1/2. So now what we're going to do is we're going to randomly pick some numbers in the three sections. So this section on the left, the one in the middle, and the one on the right. And they can be any numbers. Try to pick numbers that are easy to work with, like 0 or 1 or, smaller numbers. You don't want to go crazy. So here on the left, I'm just going to pick -5. In the middle, I'm going to pick 0 because 0 is in between -4 and 1/2. And on the right, I'm just going to pick 1. So my next step is going to be to check my solutions. Okay, so what I'm looking for are those true statements. I'm looking to see, okay, if I pick a number in one of these sections, is my graph or my function actually going to be less than 0? So let's just plug them in. 2 times -5 squared plus 7 times -5 minus 4 less than 0. -5 squared is 25 times 2 is 50. 7 times -5 is -35 minus 4. Okay, 50 minus 35 minus 4 is going to give you 11 less than 0. Well, that doesn't make sense, right? That's a false statement. So what that means is that to the left of -4, so in this region over here, the graph is not less than 0. And that makes sense, right? If you look at your graph over here in the corner over here, to the left, and to the left I mean the values for x, right? We're talking about the values of x. So as we move to the left this way, our graph is actually above the x-axis, so it's greater than 0. So you can just look at this and see, okay, to the left, our graph is not below 0, because that's what we're asking for. Okay, it's above 0, so the left-hand side is no bueno. Okay, so now we're going to check the second section. 2 times 0 squared plus 7 times 0 less than, or minus 4 less than 0. That goes to 0, that goes to 0, -4 less than 0. Well, that's good. That's a true statement. So that means that the graph is in fact below 0 in this section. So if we come over here to the corner and look at our parabola, well, that's true, okay? In the middle, the graph is below 0 there on that axis, so that makes sense. So the last section by now, hopefully, you know is going to give you a false statement, because if you look at the graph, you are going to know that it is above the axis there, but I'm going to show you algebraically how that works. So 1 squared is 1 times 2 is 2 plus 7 minus 4 less than 0. 9 minus 4 is 5. Okay, that's another false statement. So that means that the graph is not below 0. Okay, so if you look at your graph over here in the corner, we're looking at the side to the right. Okay, so this side over here. Well, clearly we can see, okay, this is above the x-axis. It's above 0, so that's not what we want. So what we're really looking at is this section of the graph. So I'm gonna draw it over here on the left-hand side. Sorry, on the right-hand side. A little bit bigger so we can see what's going on. So we've got an open circle. Do this a little bit bigger. We've got a 0 at -4 and at 1/2, okay, and they're open circles. So I have an open circle here and an open circle here. And the graph that is below 0, okay, it's going to cross at -4, is this section here in green. So what we're looking for are the values of x. So remember, x are these numbers here. What values of x will give me this part of the graph? Well, that brings us back down to step number 2 over here if we look at our number line. If I get rid of this box, okay? So the numbers or the values for x that give us the graph below 0 are all the numbers in between -4 and 0. Or sorry, -4 and 1/2, not including those numbers. So if you write that as an inequality, we're talking about the values of x that are less than 1/2, but greater than -4. Okay, remember, they're open circles. The inequality is just less than, so these are also less than. Remember, we're in big boy, big girl math, so we do set builder notation. You can also do interval notation, which is a lot easier, guys. So because they're both open circles, you have your parentheses, -4 here, 1/2. And that's our solution. That's what we're looking for. We're looking for the values of x that give us the graph less than 0. Okay, so that's it. I'll have one more example for you in a separate video if you need a little more help with this. The homework is a worksheet, I lied. The homework is the quest. So there is a 5.6B quest open for you to go ahead and get started on. Like I said, this is the last section before the exam. So once you get this done, please get started on the reviews and start getting ready for the exams.